Okay, so I just want to start our day just referring back to our factoring reference sheet. So whenever we're given an algebraic expression and we're asked to factor it, the very first thing that you always want to do is look and see if there is a greatest common factor that you can factor out of there. Okay, and then from there, depending on how many terms there are, will determine which technique you'll use. So if there's two terms, our technique is very our expressions that we can actually factor are going to be very limited. Okay, so if there's two terms, it's very restrictive. You have to make sure that if there's two terms, that it's a difference, so that there's a subtraction, and then also that each term is a square. Okay, so it's very hard to be able to factor two terms. But if you qualify, if you are two terms and a difference and you have squares, then you use the rule that a squared minus b squared is equal to a plus b and a minus b times a minus b. Okay, and that's how we're going to factor it. So this would be a good reference sheet to be able to look back on. So let's just work out these examples. X squared minus 64, well, that's the same thing as saying x squared minus 8 squared, right? X squared minus 8 squared. So when you factor that, it's an equal sign, okay? You get your two sets of parentheses, okay? And you have x plus 8, x minus 8. That's a little messy. Sorry, my stylus is not quite working. I need to get a new tip for it. Okay, and then for the second example, they have one where you do have to be careful because you have to factor. You have to do that first technique where you're looking for the greatest common factor, because a lot of times that will happen. Okay, you can divide a 2 evenly into both 2 and 18 and an n. Okay, so you pull that 2n out, and what are you left with? You're left with 9m squared minus n squared. Okay, now the only thing that you want to make sure that you do is that instead of 9m squared, you're going to rewrite this as the quantity 3m squared, okay, because you need that whole term to be squared. Okay, so now you're ready to factor. So you'll always make sure that the 2n, that's a factor, so that's staying along. And then you'll have two sets of parentheses, one's a plus, one's a minus. You'll have the first term, 3n, minus the second, which is n, or plus the second, and then times 3m minus n, okay? So that's just a little review from what we did in our previous section of factoring differences of squares. Now today we're gonna look at one of the techniques to factor three terms, okay? So for this lesson and the next lesson, we're gonna look at how do you factor if there's three terms. And so this first technique, it's kind of a shortcut, you can say, okay? So if I have a general form of a quadratic, we call this a quadratic. It's a polynomial that has the highest power of 2, okay? So we call that quadratic. We'll learn all about it next section. Anyway, but if I have this three-term quadratic where my highest term is x squared, okay? I get to use this shortcut method that we're going to learn today. Okay, and so I won't go into that right now. We'll go ahead and dive into our notes. Okay, so for a warm up, what I want us to do is go in the opposite direction of factoring. Okay, we're going to take a factored expression and simplify it, just like we had done before. So I have x plus 1 times x plus 5. So remember, when we have a binomial times a binomial, all right, we can use that nifty acronym FOIL. First, outer, inner, last, right? X times x is x squared, okay? X times 5 is a positive 5x. 1 times x is a positive 1x. You can just write 1 or x or just 1. And 1 times 5 is a positive 5. Now, the only thing that you have to do is combine like terms. Now, I want you to notice when we're combining these like terms, we are either adding or subtracting based on the signs, but we're combining these two x terms together, okay? So we have positive 5 plus 1. That's going to give me a positive 6x. So I have x squared plus 6x plus 5. So let's take a second really quickly, and this will make sense later. Where did we get this 6 from? We got this 6 from adding these two pieces, the 5 and the 1. Or where'd those 5 and 1 come from? Right there. We added those together and we got the 6, okay? Where did we get this 5 from? Well, we got the 5 from this very last piece, 1 times 5, okay, right? 1 times 5. So we got that 5 from multiplying these two together. So this is going to help us whenever we're going in reverse and we're factoring. These two numbers, okay, are going to help us determine what my two pieces are right here. Okay, and I feel like I'm coloring all over the place and maybe it doesn't make as much sense. So let's just do a few more. This, like I said, you might not understand that right now, but let's work out a few examples and see that connection between all of those. Okay, and I'm gonna erase all that. Okay, so moving on. My second example, if I wanted to simplify this, I would distribute. Okay, I would distribute. And so I have m squared minus 4m plus 6m minus 24. Okay, we're going to combine these terms, m squared plus 2m minus 24. Once again, where did this 2m come from? Where'd the 2 come from? Well, it's by taking this negative 4 and this positive 6 and combining them. That's right here, the negative 4 and the positive 6. Where did we get the negative 24? From multiplying the negative 4 and the 6, okay? So whenever I give you a simplified expression like this, how are we going to be able to go backwards, okay? We're going to be able to use those ideas that, hey, my two constants have to multiply together to get that one, and they have to add together to get that one, okay? And so, like I said, let's just work some examples out. It's a little bit more confusing, just explaining without seeing it. Okay, and then our very last one, k times k times negative 3, and so on. So k times k is k squared, k times negative 3 is negative 3k, negative 7 times k is negative 7k, and then negative 7 times 3 is positive 21. We combine those terms together, k squared minus 10k plus 21, okay? So what we're going to do from here on is now I'm going to teach you, you've always known how to go this way, taking the factored form and simplifying it. Now let's take time to learn how to do it the other way. If I give you the simplified form, can you write it in the factored form? And so I'm going to stop the video here and we'll continue in the next guy.